Good morning. Not good morning, good afternoon. Today, we are going to carry on our example. We are going to carry on our example on relative motion analysis. Okay. And then after that, we're going to look at velocity. So I have posted this on Avenue to Learn. Okay, so we're going to look at this example first. Oh, the screen is not there. I do apologize. I was so focused. No wonder something looks weird. The screen on? Thank you for telling me. I knew something was off. You guys were still talking. I knew like I was off. Right. So let's start again. We're going to finish one last example of relative motion analysis. Then we are going to relative motion analysis in terms of velocity. Okay, so we're going to start with this first. So this is the last example of relative motion analysis. Okay, so we're going to do this example first. So what we have at the instant shown, the disk is rotating with an angular velocity of omega and an angular acceleration of alpha. Determine the velocity and acceleration of cylinder B at this instance and neglect the size of the pulley at point C. I will add something further. Okay, we are also going to find the stress acting on the rope from at or along point C to point B, where diameter of the rope is let's call it 25 millimeters, and the mass is 20 kilograms. Okay. So this is such a typical mechanics problem. Okay. And what is the difference over here is whenever we summon the forces on the rope, it's not equal to 0. We have to include the what? Acceleration component. Yes. So that's where we are here to find the what? To determine the what? The velocity, and more important over here is the acceleration. Okay, so mind you, I don't have to look at this. Okay, 2Q, just math. Okay, there's nothing to do with real life. Yeah, partly true. Okay, but what's going to be worse, okay, is we put things realistic like this. After you all come back from your reading week, I'll show you how bad things can get. Okay, so we are going to do velocity of both the piston, but more important, gears is our business. We will learn how to calculate velocity on planetary gears. Okay, you guys are learning gears now, yes or no? You guys are learning gears, and usually when you handle gears, it's under what? Simple gear train, am I right? Okay, where you have one gear on the left, one gear on the right. How often do you see gearbox work like this, where you have one gear on the left, one gear on the right? Never. Which gears is most often seen? This crap that you see down here. Are we clear? So have a happy Thanksgiving first, then we come back with a lot of turkey and beef in your tummy. We should be able to handle it. It is not what? Difficult at all. Are we clear? Okay, if it's difficult, I will not be doing it. Okay. I mean, not really, but anyway. Right, so let's look at this problem over here. So the first thing, like what we have, right? So we know that we have to find velocity of AC and acceleration, or I put small a, of AC. And because of it's a rope, this happened to be velocity of AC also, and acceleration of AC. Okay, let's focus on that. So we have a relationship. Remember, this topic is about relating geometries, right? So what we have is we know the distance. So I'm going to call this point A, B, C, point D. Okay. So we know that we have a triangle ADC. We know there's an angle theta, right? So the first thing is we are able to relate what? We are able to relate in the sense of distance. So we know that S squared is, if I'm going to call this A, I'm going to call this B, and I'm call this S. So this is equal to A squared plus by B squared minus 2AB cos theta. A formula that looks very familiar. Yes or no? What do you call this? Cosine rule. Okay. So from here, now you already linked the geometrical part. So what we need to do is find what is S first. Okay. So we know that S is equal to square root of A squared plus by B squared minus what? 2AB cos theta. So what we need to do is we need to what? Integrate this equation how many times? 2 times, right? Once in terms of velocity, and after velocity, we integrate again, we get what? Acceleration. Okay, so before we do that, start putting in the numbers. Okay, so this is S. So this is our A squared is equal to what? 3 squared plus by B, 5 squared, minus by 2 multiplied by 3 multiplied by 5, and then we have a cos theta, the whole thing close bracket, and then we powered it by half. Okay, so 3 squared plus 5 squared equal to 34 minus by 2 times 3 times 5, 30 cos theta power by half. Okay. Then we take the first time derivative. So we know that we can do ds by dt. So this is in fact BAC, right? So if you differentiate this, so you differentiate with the half down here, right? You have 34 minus by 30 cos theta, power of minus half, multiplied by cos to sine, you got positive 30 sine theta, and we are differentiating d theta over dt. Why we do d theta over dt? Because theta is going to be a function of what? A function of time. Okay, so once you put everything in, we have 15 sine theta divided by 34 minus by 30 cos theta, about half d theta over dt. And then note, of you are aware, d theta over dt is also equal to what? Omega. So from here, we know that this is equal to 15 omega sine theta. And then what we have over here is we have 34 minus by 30 cos theta power of half. Okay. Be careful over here. Remember, do not forget to include the what? Include the omega. Okay. We have marked 20% of the term test. I'm so glad class average was 79. Okay, so just 20% of you. I don't know exactly who. So I'm having hopeful. I think you guys can enjoy your Thanksgiving. Don't be stressed. Okay. Right. So from here, we need to do what? We need to do a d squared s over dt squared. Okay. So next we do a d over dt, or this is in fact acceleration of AC. Okay. So this is equal to d over dt. And then you have 15 omega sine theta over 34 minus 30 cos theta power of half. Okay. I think I need to apply product rule, am I right? Or chain rule for this. What do you call it again? Huh? Never heard about it, but I'll try. Okay. So I'm only aware that I need to let you listen. In England, we just learn the technique. Okay, whatever name it is, I got not a freaking clue. Okay, or I've forgotten. Okay, so you are right. Whatever do you call it, I'm not going to dispute. Okay, so now we are going to let small u. I'm not a clue, man. Is equal to 15 omega sine theta. My advice to you is to underline what variable is a time function. Again, I advise you to write down, to underline what variables are the time function. Is omega a function of time? Anyone? It is. Is theta a function of time? It is. So when that's the case, when you do du by dt, right, you have to do 15 sine theta d omega over dt plus 15 omega cos theta d theta over dt. Okay. So this is your u. Then we're going to let small v will be equal to 34 minus 30 cos theta power of half. Then you underline which one is a time variable. So for this case, it's very obvious. So now you have your dv over dt. Okay, so this will be equal to half 34 minus by 30 cos theta power of minus half again. Okay, and then we have to have a bracket. So we have to have minus cos theta change to, so we have 30 sine theta multiplied by d theta over dt. Don't put up your hand. If you have not a clue what I'm doing, start to worry. If you have an impression of what I'm doing, you guys are okay. Are you okay? Are you okay? No answer. You're scaring the crap out of me now. Are you okay with the math? Yes. Okay. You guys, I told you, right? Your math, you guys learn so much in math that make me look like a Mickey Mouse. So this is equal to 15 sine theta. And then over here, we have divide by 34 minus by 30 cos theta power of half, and then I just need to write d theta over dt. Okay, I'm just going to leave it at that. So by now, we can now formulate okay, by now, I'm going to become a tree hugger. I'm just going to, you guys are Eugene, what tree are you hugging? So so we know that we're going to do d squared s over dt squared. This will be equal to v du by dt minus by u dv over dt divided by v squared. What is this called again? How? Can you spell?